Welcome back, everyone. Today we're going to go over the proof of the tangent power reducing identity. So let's dive in. So here we have that tan squared a is equal to 1 minus cosine of 2a all over 1 plus cosine of 2a. So the first thing we're going to do here is we are going to recall that tan squared a is equal to sine squared a over cosine squared a, right? And we know that this is true because we know that tangent of a in general is equal to sine a over cos a. Therefore, tangent squared a would be equal to sine squared a over cosine squared a. So let's start with that tangent squared a is equal to sine squared a over cosine squared a. Now we need to be able to express both of these in terms of cosine of 2a. So let's also recall the double angle identities, right? That cosine 2a is equal to cosine squared a minus 1, 2 cosine squared a minus 1. And then that cos of 2a is also equal to 1 minus 2 sine squared a. And so then what we can do is we can take those things that we just recalled and solve for cosine squared a and also for sine squared a. So let's first take this one right here and solve it for cosine squared a. So that's going to give us cosine 2a plus 1 equaling 2 cos squared a. And then if we divide both sides by 2, we get that cosine squared a is equal to cosine 2a plus 1 all over 2. So that's our first identity from the recall that we're going to use. Now we're going to go ahead and do this one next. So for this one here, the purple one, if we add 1 to both sides, we get that negative 2 sine squared a is equal to cos 2a minus 1. And then if we divide both sides by negative 2, we get that sine squared a is equal to 1 minus cosine 2a all over 2, right? Because here we divided by negative 2. And so once we divided by negative 2, in order to get rid of that negative, I multiplied it through. And that's why instead of cos 2a minus 1, we ended up with 1 minus cosine 2a, and the sign swapped there. All right, so there's our second equation. So now I'm going to go back to up here, and we're going to sub those things in. So now we know that tan squared a is equal to 1 minus cosine 2a over 2 all over, cosine squared a was 1 plus cos 2a all over 2. And then the divided by 2's just cancel out. So then we get that tangent squared a is equal to 1 minus cosine 2a all over 1 plus cosine 2a, like that. And if we go back, that's exactly the identity that we sought out to prove the whole time. As always, any questions, please leave them in the comment section, and we'll see you for the next one.